Alright, here we are with a new topic, the Pythagorean Theorem. This is an application of geometry for right triangles, but it uses a lot of things we've learned in algebra this year, such as squaring and square rooting, a lot of times simplifying numbers with radicals in them and stuff like that. So it's kind of a nice extension of what we've learned. So to use Pythagorean Theorem, or the idea of Pythagorean Theorem, is that you can find the lengths of the sides of a right triangle. So it has to have a right angle, and you have to be able to identify what the right angle is. So in my picture, the right angle is right here. And we call the two sides of the triangle that are adjacent or next to this right angle the legs. So in this case, A and B are legs. So this one right here and this one right here are the two legs of the triangle. And then the hypotenuse is the opposite side of the angle, which is always the longest side of the triangle. So you need to identify the two legs and the hypotenuse, and it's important to get them right because otherwise you'll get your formula mixed up. So the Pythagorean theorem is a relationship between the side lengths of the right triangle. A squared plus B squared equals C squared. So if you take this length here, whatever distance that is, and whatever distance this is, and you plug them in here and here. So you square the length of the first one, you square the length of the second one, you add them together, that will equal the length of the hypotenuse squared. So it's a really cool formula, and it's kind of abstract. It doesn't really make sense why that should be the case. So in the next slide, we're going to prove this formula, and the proof is definitely going to use a lot of the algebra skills that we've learned this year. So here we go. If you take a picture like this, you can make a big square with side length A, which is that distance, plus B, that distance. Okay, and this side is the same, A plus B. So the total outer square, which encompasses all the blue and the yellow, your outer square, the area is A plus B squared, because that's the side length. This side is A plus B, this side is A plus B. The inside square here is obviously C squared. And the blue part, there are 4 triangles, right? And each triangle has a base B and a height A. So this one has a base B and A, B and A, B and A. And the formula for a triangle is 1/2 base times height. So you got a 1/2 base B, height A. Okay, so the whole thing is A plus B squared. The inside is C squared, and the blue part is 4 times 1/2 BA. Now we know the blue plus the yellow has to add up to the total. So these two things added together has to equal this thing. So let's write that. A plus B squared, that's the total, has to equal C squared plus 4 times 1/2. What's 4 times 1/2? 2. BA, we'll write that as AB. Just change the order. Okay. Now let's use our skills with squaring out binomials. You might be tempted to write A squared plus B squared, but remember, because this is plus or minus inside parentheses, we should write A plus B times A plus B and expand it out using FOIL or a rectangle diagram. Or better yet, if you remember, this is a perfect square, and there's a simple, remember, shortcut here, A squared plus 2AB plus B squared. So all of this came from that using the binomial expansion, which is just a shorter way of saying, or a longer way of saying FOIL it out, equals C squared plus 2AB. And now you can see that the 2AB right here and the 2AB right here, if we subtract 2AB from both sides, those cancel, leaving you with A squared plus B squared equals C squared. So it wasn't too bad to prove. We just had to use our geometrical skills by looking at the shapes, triangles, and squares, and our idea of squaring out a polynomial or a binomial in this case to get the formula here, relating the length of the sides. So very cool. And it's neat because if you know the two sides of a triangle, you can find the third side. So let's try a couple examples. Suppose we have a right triangle right here with side length 3 on this side and 4 on this side. So these are 2 legs, right? So it might be nice to write A equals here and B equals. So we can really cement in our mind that these are the legs and this is the hypotenuse that we're trying to find. Because if you get the legs and the hypotenuse backwards or mixed up, then you're definitely not going to be getting the right answer. We know this hypotenuse has to be longer than either side, so that the answer has to be bigger than 4. Okay, let's write our formula here. A squared plus B squared equals C squared. Plug in our numbers. 3 squared plus 4 squared equals C squared. 3 squared is 9. 4 squared is 16. Add these together and you get 25. Take the square root and you get 5. Technically you get plus or minus 5, right? Remember when you take square roots you get plus or minus, but because we're finding the length of a side, we know it doesn't make sense to keep a negative answer. So this side is 5. And actually, I chose these numbers because they work out nicely. This is a 3, 4, 5. It's called a special right triangle. Because they're all whole numbers, it's a very commonly used example in math problems, especially on standardized tests. So it's a good one to remember, a 3, 4, 5 special right triangle. Okay? Oh, I've made a mistake here and I've accidentally given away the answer. So let me pretend that we didn't know what that answer was. Let's say b equals question mark. Okay? So let's identify, this is the hypotenuse, so this is going to be our c value, and this is our a value, a or b. A and b are interchangeable. It doesn't matter whether you call this one a and this one b, or vice versa, just as long as the two legs are a and b, and the hypotenuse is c. So let's set up our equation. A squared plus b squared equals c squared. Plug in all of our numbers. A, we had 5 squared, plus b squared, b is the one we don't know, equals c squared, 13 squared. So this is why you have to be careful to get them labeled correctly. If you're not paying attention, it's easy to just take the two numbers that you know, 13 and 5, and plug them in for a and b and add them together. But if you know the hypotenuse, it's important that you put it on the other side of the equal sign. And it's important also that when you get your answer, use common sense. Our answer for this leg has to be smaller than 13. So if you do it wrong, you'll get an answer that doesn't make any sense. All right, let's solve this equation out. 5 squared is 25, plus b squared equals 13 squared is 169. Now subtract 25 from both sides. Cancel, so you get b squared equals 169 minus 25 is 144. And if you take the square root, you get b equals 12. Again, plus or minus, but we're only keeping the positive value because that's the one that makes sense. And as you saw, there was a 12 that I had scratched out. So this is another nice one because the numbers worked out well. We got 5, 12, 13. That's another very commonly used one on tests. I just want to point out, if your answer would have been something that had a nasty square root, like suppose we solved this little triangle and we got out our answer b equals the square root, or b squared, so yeah, b squared equals 150, and then we took the square root of both sides, right? And you get b equals square root of 150. Well, we already learned this year how to simplify radicals. So you could write this as, you could break it down as 25 times 6, and then you could write b equals 5 root 6, something like that. So a lot of times, they won't work out to be nice whole numbers, and you'll need to simplify them using the properties of radicals that we learned earlier this year. And that's it for this situation.